writing redox equations. Now this is why we bother with oxidation numbers, so that we can go on and write equations. Because following a few rules, a few not too difficult rules, we can write equations for what looks like really complicated chemical processes. Just got to follow the same steps every time. Now the first of those steps is to use oxidation numbers that we've been doing, exactly what we've just done. Use oxidation numbers to identify what's being oxidised and what's being reduced, and then turn that into skeleton half equations. Then we'll use a method to write balanced half equations and then combine them to an overall equation. So what we're going to start off with is getting those skeleton half equations using our oxidation numbers. So we'll get a scenario like this and be asked to balance that equation. And the first step is to work out what's being oxidised, what's being reduced, give ourselves balanced skeleton half equations to balance. So let's just arrange that bit of text into reactants and products, get the formulas. So we're given the complicated ones. So we've got K2MnO4 reacting with concentrated hydrochloric acid. Well, we know that's HCl, so that's our two reactants. K2MnO4 plus HCl gives chlorine gas, Cl2, plus just manganese ions, Mn2+. So just getting that information into a skeleton equation, just arranging the information into reactants and products and getting the formulas there. Now, potassium ions are a little bit problematic there. Now, we've got oxygens and hydrogens, it doesn't matter. They can be anywhere in the equation. We take care of them later on. But the other elements really should be on both sides of the equation so we can balance it. Now, potassium ions in this case are on the left-hand side but not the right-hand side. And they're acting, so they're not being part of a product, therefore they're spectator ions. So we just leave them. Leave them out. Nothing happens to them, so we leave them out. It becomes an ionic equation. So that's our skeleton equation. Next thing to do is to use oxidation numbers to identify oxidation and reduction skeleton half equations. So the manganese oxide there, what's the oxidation numbers of it? Well, 4 oxygens gives us -8. The overall charge on the ion is -2, therefore the manganese has to be +6. HCl is pretty straightforward. Cl2, of course, is free element, oxidation number of 0. Mn2+ is a simple ion. So what's happening? Well, the manganese is going down from +6 to +2, so the manganese 6 oxide is being reduced. Chlorine is going from -1 up to 0, therefore the HCl is being oxidised. So we can write 2 skeleton half equations. What's being oxidised? So the manganese MnO4 2- is turning into Mn2+. The HCl is turning into Cl2. As I say, we just need to make sure don't worry about the hydrogens and the oxygens, it's the other elements that we need to make sure are properly part of the equation. Don't need to be balanced, we just need to make sure they're present on both sides. So that gives us 2 skeleton half equations. First step done.